Today we're going to review the Learning Target 6.1, which is all about analyzing systems. So one of the things that we are going to be doing when we analyze systems is determine whether or not an ordered pair is a solution. So when I ask, is it a solution, I'm giving you an ordered pair. And remember, an ordered pair has x first and y second. So then I'm giving you two equations, and what you're going to do is you are going to take the top equation where I see x, I want to substitute in -4. Where I see y, I want to substitute in +4. So I won't have any more variables, but I just want to know, does the left side, when I substitute in those numbers, really equal 4? And then the same idea with the bottom equation. Wherever I see an x, I'll substitute in -4. Wherever I'll see a y, I substitute in +4. So let's start with the top. So we're going to have -4 plus 2 times +4. And once again, I want to know, is that going to equal 4? So I am going to multiply first. 2 times 4 is 8. And so now I want to know, is -4 plus 8 going to be +4? Well, yes, that checks out. So far, so good. If I look at the bottom equation, it starts with y. So I have to put 4 first. That's going to equal, now I want to plug in the -4 into the x. So I can't do anything to the left. I want to simplify the right and see if I have a true statement. So when I multiply, -2 times -4 is +8. I still want to subtract 3. Well, what is 8 minus 3? That's 5. So notice that in this case, I got a true statement with the first one, but not a true statement with the second one. I have to have two true statements in order to say that I have a solution. So the moment I have one false statement, I'm going to say, no, it is not a solution. And this is because both statements are not true. And that's how we determine whether or not we have a solution. All right, let's move on to the concept of the best method. So sometimes I might ask you, what's the best method to solve? So we have three different ways of solving. We have graphing, substitution, and elimination. So remember, with graphing, I want to see both equations in the y equals mx plus b form. Okay, if both equations don't say y equals, then graphing is not the best method to use in order to solve. For substitution, we want one variable isolated by itself. So when I'm looking at my two equations, I'm looking for an equation that says x equals, or I'm looking for an equation that says y equals. It doesn't have to be both equations. It's just one equation that has one variable isolated by itself. As far as elimination, we want all like terms lined up vertically. So that means that I want the x's one on top of the other, the y's one on top of the other, the equal signs one on top of the other, and the numbers one on top of the other. So now that we know that these are the ways in order to solve the best, if I look at this example, it says match the best method to solve each system. So let's look at the one on the far left. We have x equals 4y minus 21 and 2x minus 8y equals -42. Hopefully we notice that this top equation, it says x equals. So because I have a variable that is isolated by itself, that tells us that substitution is going to be the best method to solve. If we look at the middle example, we have y equals -3/2 x plus 1 and y equals 1/2 x minus 3. Notice how both of these say y equals. They're in that y equals mx plus b form. So that tells us that graphing is the best method to solve. If I look at this last example, we have negative 14x plus y equals negative 25. And then in the bottom equation, we have 7y, or sorry, this should be an x. I'm so sorry, I typed that wrong. 7x plus 3y equals 23. So notice that I've got the x's lined up on top of the other. I've got the y's lined up on top of the other. I've got the equal signs lined up on top of the other. And then I've got the numbers. So I've got everything lined up vertically. All my like terms are nice and lined up. So that tells us that elimination is the best method here. Okay, the last thing I want to review is the types of solutions. So if I'm looking at a picture, to get one solution means that I want to have two lines on the graph that are going to intersect at one point. Okay, if I was actually solving instead of graphing, if I wanted to figure out the type of solution and I was doing substitution or elimination, we would get a number for both x and y, which means that we would be able to come up with an ordered pair x, y. Okay, if I have no solution, as far as what it looks like as a graph, that means that I would have two lines on the graph that are never going to intersect. Those are parallel lines. If I was solving using substitution or elimination, we would then end up having both variables disappear and we get a false statement. So if I'm solving doing substitution or elimination and all the variables disappear, we get something like 2 equals negative 1. Okay? Well, 2 does not equal negative 1. That's a false statement that tells us that we have no solution. And then as far as infinitely many solutions, I would then on a picture only see one line because technically I would have one line on top of the other. We'd have two exact same lines, so you'd only see it once when graphing. If I was doing substitution or elimination and I have infinitely many solutions, that's because both variables disappear and we get a true statement. So something like 5 equals 5. That is a true statement, and so that would tell us we have infinitely many solutions if I solved using substitution or elimination.